Hi, second year students. It's math with AUB. Somebody has shared with me new book, 121 pages of National Book Foundation. Watermark is written on it with red, and I have pondered over that. I have to start from integration. Everybody has started from derivative. They are familiar this and that. So let's take a path that is not normal, that is not usual, unusual, extraordinary. To start from where? Integration, anti-derivative process. Anti-derivative process, everybody is familiar. Let me start in retrospective fashion, reverse fashion. Our question number last, our 18 is z raised minus 1 over 4 plus root 3 times z plus 4 over z negative 1 over e raised z dz. Here, dz is the indication that z is our variable. Z is our variable. First, apply simple integration. Simple integration. Simple integration. Ask yourself, is it derivative of something? Is it derivative of something? Look at this. If we are in a position to multiply integration symbol and dz throughout, and it's really very easy. Z raised minus 1 over 4, it is a reverse process of differentiation. We add 1 and divide with the power. Here z raised 1 over 2, it's simple one. Add 1 into the power, divide with the same. Here there is 4 over z, 1 over z, 1 over z. 1 over z is the derivative of ln z, so its integration is ln z. 1 over ez, it can be transformed as e raised minus z, and derivative of e power minus z we are familiar. Let's see how. Just multiply throughout integral and dz. Z raised minus 1 over 4 dz. It is simple integration. It is simple integration. Add 1 into the power dividing with the same. If we add 1 into the power, it will become 4 LCM minus 1 plus 4. It is z raised 3 over 4 dividing with the same. Dividing with the same. In differentiation, we subtract one power and make the power coefficient. Make the power coefficient means we multiply with the power in case of differentiation. Here, add 1 into the power, decreasing 1, opposite of decreasing 1 is increasing 1. Multiplying 1, then dividing by the power. Add 1 into the power, divide with the same power. Add 1 into the power, divide with the same power. So this one can be written as 4 over 3 z raised 3 over 4. I have handled just first term in order to give you good view. It's simple integration. What about the next? Under root 3 is a constant. Root z can be written as z raised 1 over 2. It is also a simple case. It's also a simple case. Add 1 into it. 1 upon 2 plus 1. It will give us 3 over 2. 1 upon 2 plus 1. 2 LCM 1 plus 2. 3 over 2 is our answer in that case. Plus root 3 z raised 3 over 2 dividing with 3 over 2. Settle it down. 2 will be in the numerator. 2 times root 3 overall 3 z raised 3 over 2. 3 over 2. What about this? It's really simple one. If I write 4, then 1 over z dz. I have written 4 outside, 1 over z. Ask yourself, 1 over z is differentiation of ln z, ln z. So, its integration is reverse process of differentiation. 1 over z, derivative of ln z is 1 over z. Differentiation of ln z is 1 over z. By virtue of that definition, integration of 1 over z is ln z. ln z, or one can write mod z because it is always positive. Okay, here minus 1 over ez, minus 1 over ez, minus 1 over ez. It can be written as minus e raised minus z, e raised minus raised dz. I have switched from denominator to numerator, taking e power minus z, e power minus z. This one 4 times ln z. Differentiation of e raised z is e raised minus z. Its integration is e raised minus z. But look at this. Differentiation of minus z is minus 1. So dividing with this minus 1 plus see integration of constant, settle it down. It will become minus minus plus this is our 4 over 3 z raised 3 over 4 plus 2 times root 3 over 3 z raised 3 over 4 plus 4 times ln z or mod z minus minus plus it is e raised minus z plus c, or one can write this one as 1 over e power z, 1 over e power z. This one same 4 over 3 z raised 3 over 4 plus 2 times root 3 over 3 z raised 3 over 2 plus 4 times ln z. It can be written as 1 over ez or e power minus z in numerator. It's same. It is our answer in that case. It's our answer in that case. It's simple one. Add 1 into the power dividing with the same. Add 1 into the power dividing with the same. This is tricky part. This is also tricky part. Let me explain to you these two, taking individually and explaining to you again. Taking only these two terms in order to give you good view. Where is the problem? Hit the nail on the head rather than somewhere else. Let me clarify the situation. 4 times 4 over z dz minus 1 over e raised z dz. 4 is a constant, can be settled, can be written as dz over z minus e raised z. It can be written as e raised minus z dz. Look at this. There is 1 over z, 1 over z. 1 over z is integration of ln z. Integration of ln z, or keep one thing in mind, z raised minus 1 dz. Minus 1 is the exception in case of integration. We do not add 1 into it. Z raised minus 1 dz, minus 1 power is the exception. Don't add 1 into it. If we add 1 into it, then what happens? 0 dividing with 0. So division with 0 is not allowed. Division with 0 is not allowed. And simply ask yourself, 1 over z is the differentiation of ln z. So integration of 1 over z is ln z, ln z, ln z. Z raised minus 1 is exception. Don't add 1 into it. Don't add 1 into it. It is case of ln 1 over z. Ask yourself, is it derivative of something, differentiation of something? 1 over z, it is differentiation of ln z. So its integration is ln z. Differentiation of ln z is 1 over z. Ask yourself, is it differentiation of something? Yes, it is differentiation of ln z. Minus here, this is our second case where base is constant, power is variable. Base is constant, power is variable. How we can differentiate e in that case? Derivative of e raised to negative x with respect to x. We write it same. Differentiation of power minus 1 and base with ln. Base with ln, it will become ln e. We are familiar, ln e is 1. Ln e is 1, so it is minus e raised to minus x times 1. It's our differentiation. It's our differentiation. In the same token, here, the integration of e power minus z is minus z. We have to divide with these two. In case of differentiation, multiply with them. Integration is a reverse process of differentiation. Dividing with these two, it will become minus 1 times ln e. Ln e is 1 minus minus plus. So it will become something like this, 4 ln z plus minus plus e raised to minus z over 1 plus c. Or converting this power into power positive, you can write, and utilizing here tiny property of log, coefficient will become power ln z raised 4 minus plus 1 over e raised z plus c. Either you can leave here, or you can write this as by virtue of a tiny property of logarithm, log, as well as e raised to negative z. From simple exponent rule, we can convert this one into positive by writing 1 over e z. It is simple integration. Just add 1 into it. Minus 1 over 4 plus 1, it will become 3 over 4, dividing with the same power. Z raised 3 over 4 dividing by 3 over 4. Here z 1 over 2, it is also simple one. Add 1 into the power 1 over 2 plus 1, it will become 3 over 2. Z raised 3 over 2 divided by 3 over 2. Here I have explained to you 4 over z means 1 over z. 1 over z, it is differentiation of ln, so its integration is ln z. Here e raised negative z, in that case we haven't differentiated this way. In that way, we have written either apply quotient formula in case of differentiation, or write in that fashion. That I have explained to you in a good fashion. Let me explain to you again. Look at this, e raised negative 3x, say suppose its differentiation. To me, it is base constant, power variable. How to differentiate this one? Simple hack. Write it same. Differentiation of power minus 3x, differentiation minus 3, base with ln. Base with ln. There is the ln. ln is 1. ln is 1. It is our answer, minus 3 raised e raised to minus 3x times 1. In case of integration, we have to divide with both of these quantities instead of multiplication. 3 times ln e. ln e is 1, so it will become e raised to minus 3x over 3. E raised to minus 3x over 3. In our case, we have e raised minus z, that is in start 1 over e raised z dz. I can write this e power minus z dz. Keeping its differentiation technique in mind, its integration is same. Divide with the derivative of the power minus z means minus 1, and write base with ln. There's no problem in that. ln is 1, so minus e raised minus z over 1. That's our integration in that case. 1 over z means ln z. It can be written as e raised minus z. Integration of e power minus z is e power minus z. Whatever is derivative of the power, it's minus 1. Base with ln. We have to divide with this quantity. To me, it is base constant, power variable. To me, it's base constant, power variable. Okay. Moving on a step further, what I have next, it's also E and ln technique 17 question, that is 5 times e raised 5x minus x raised to minus 3 plus 3 raised 2x, that's dx. It is simple integration. Look at this, e raised 5x, it's simple case. X raised minus 3, it's also. Let's see and find out how. 5 times, let me take a space, 5 times e raised 5x dx. I have taken these two. Ask yourself, to me it is second kind of data. In derivative, differentiation and integration, there are 3 types of data. Normal, base variable, power constant. Base variable, power constant. Second technique, base constant, power variable. And third is base variable as well as power variable. You must have distinction in all 3 categories of the data present in differentiation. While there are 2 formulas, product rule and quotient formula as well as chain rule. Quotient formula, product rule as well as chain rule. But these are the 3 types of data they are present. Look here, base constant, power variable, base variable, power constant, base constant, power variable, base constant, power variable. It is the tricky part. How to integrate this one? Write it same. Divide with the derivative of the power. Differentiation of 5x is 5 times 1, and introduce e with ln, base with ln. In case of differentiation, we have to just multiply these 2 quantities. In case of integration, instead of multiplying, we have to divide. 5 cancel, ln e is 1. So Integration of 5 raised e power 5x is only e raised 5x. E raised 5x. E raised 5x. Here x raised minus 3. It's my normal case. Sorry, there is negative x raised minus 3 dx. It's first category, base variable power, constant, add 1 into it, it's simple integration. It will become minus 2 dividing with the same, negative, positive, 1 over 2 x raised to minus 2. And what about this? This is also our second case, base constant power variable. Base constant power variable. Write it same, 3 raised e power 2x. 3 raised 2x, sorry, 3 raised 2x. I have said ex. 3 raised 2x, same. Divide with the derivative of power 2 times 1. Derivative differentiation of x is 1. Write base with ln. That's our ln 3 plus c. So I have 3 raised 2x overall 2 times ln 3 plus c. That's our answer in that case. That's our answer in that case. In case of E, ln E is 1. ln E is 1. It is no more ln E. Here ln 3 is present. ln 3 is present. That's our answer in that case. You can convert this negative power to positive by writing 1 over 2x square. 1 over 2x square. Here, let me give you a good idea about its differentiation. Look, 3x square plus x plus 1. Hunt the data, classify the data. Its base constant power variable. Base constant power variable. Its differentiation is given by right same, complete data same. Differentiation of power, x square 2x, x1 1 0. Introduce 3 with ln 3. ln 3. That's the differentiation. In case of integration, we have to divide with this. That I have done here. 3 raised 2x, same. Differentiation of 2x is 2, and base with ln. That's ln 3. That's our ln 3. Now you have good view about this. There are 3 types of data: base variable, power constant, base constant, power variable, both variable. If base constant, power constant, then it is a pure constant and its differentiation is 0. 17. Look at this. Question number 16. 3x square plus 2x x cube x square plus 9 overall 5 dx. Here our horizon expands. Look at this. Write 5 times, open this one, 3 terms, trinomial having power 5. Whenever power is fraction, power is larger, power is fraction, power is larger, power is negative, try to ask yourself, is it function derivative situation? Function derivative. Look at this, it has greater power. There is a probability that it is our function. That's its our function. Take its base only. Differentiate x cube. Differentiation of x cube is 3x square. Differentiation of x square is 2x. That's our function. That's our derivative. It's our function. It's our derivative. Then we can apply simply substitution by adding 1 into the power, dividing with the same, and we have done in that case. Let me arrange this. Write function first. X cube plus x square plus 9 raised 5 times 3x square plus 2x dx. It's our function, it's our differentiation. Function derivative. If you want function and derivative in case of integration, it works wonder for you. It's some type of Aladdin's lamp. Just rub it and everything goes 100% correct. Function derivative. Function, look at x cube 3x square 2x 9 0, no more. Function derivative. Add 1 into the power of the function and it's our integration. X cube plus x square plus 9 raised 6 divided by 6 plus c, and it's our answer. Direct, without any effort. Some people take some trouble. Suppose it is equal to y, differentiation it is dy, y power 5 dy. It's also same. But that is the tip or trick in that case. Let me apply proper substitution that mostly propagate to you. Okay, writing function first, differentiation later, is 5, 3x square plus 2x dx. Suppose, assume y is equal to x cube, x square plus 9. Look at the beauty. I haven't taken the overall power. That is the problem. That is the problem. I don't want to open this right 5 times and multiply. I want to get rid of this. That's why I have taken this strategy. Suppose the base and its differentiation. It's wonderful. Differentiate with respect to x, dy over dx. I have 3x square plus 2x, 9 is 0. Shift differential dx here. Differential dy is equal to 3x square plus 2x times dx. That's R2, that's R1. Put here. It's Ry raised 5, it's R dy. Put values in that. I have y raised 5 and 3x square plus dx is R dy. Look at this. It's simple integration. Normally, we have only one variable. Add 1 into the power y over 6 dividing by 6. We put the value that we have assumed y is equal to x cube plus x square plus 9. So it can be written as 1 over 6 x cube plus x square plus 9 raised 6 plus c. It's our answer. Whether to take this part or direct function derivative, add 1 into the power of function. Function derivative works wonderfully. Function derivative works wonderfully. Okay, moving towards next questions. Now they seems to you just tiny ones because we have done a great deal. 15 one is simple one. X raised 3 over 2 plus e raised 3x plus x raised 0 dx. Obviously, in our case, x does not equal to 0. X does not equal to 0. If x is equal to 0, then this data is nothing but a constant. This data is nothing but a constant. Simple case, base variable power constant, and there is single x. Enhance 1, it will become 5 over 2 divided with the same. There is x raised 0, 0 plus 1 divided by 0 plus 1. This one, base constant, power variable, write same, divide with the differentiation of power, introduce base with ln. Let's see how. Just distribute integral symbol and dx throughout. X raised 3 over 2 times dx plus e raised 3x dx plus x raised 0 dx. Add 1 into the power, it will become 5 over 2 divided by 5 over 2. R1 can take the trouble. 3 upon 2 plus 1, taking 2 LCM, 3 plus 2, 5. It's the case. Base constant, power variable, write it same, e raised 3x. Divide with the differentiation of power, 3, differentiation of x is 1, introduce base with ln, plus x raised 0, it's simple case, 0 plus 1 divided by 0 plus 1 plus c. So we have, it can be written as 2 over 5 times x raised 5 over 2 plus 1 over 3 e raised 3x, ln e is 1, that's why it's no more, plus x 0 plus 1 over 1 plus c. That's our answer in that case. Moving towards next question. It's a good one. Let me solve two for you. 14 and 9, they are almost of the same type. Let me explain to you these two. Write them together. 9 x times e raised x square dx and is 14, that is e raised tan inverse of z over 1 plus z square dz. Before directly integrating this, let me refresh in your memory. If that is the question to you, e raised f of x, and you are asked to differentiate, how you can differentiate? Base constant, power variable, you write same, differentiation of power f dash x introduced best with ln e. We know that ln e is equal to 1 e raised f of x f dash of x. So differentiation of e raised f of x is differentiation of e raised f of x is e raised f of x into f dash x. So if we integrate this one, e raised f of x f dash of x dx, and here e raised f of x dx, derivative integration cancel out, so e power f of x is the integration of e raised f of x times f dash x dx. So integration of this one is e power f of x, e raised f of x times f dash x dx. Its integration is e raised f of x. By virtue of the definition of this case, I used to call it base constant power variable. Base constant power variable. Both situations are prevalent here. Differentiation of x square is 2x. Deficiency of 2 divide and multiply by 2. Apply that tip. In that case, tan inverse z. Differentiation of tan inverse or arc tan is 1 over 1 plus z square. 1 over 1 plus z square, that is present over here. Just apply this tip. How I can manage for you? It can be written as e raised x square times x dx. Differentiation of x square is 2x. Differentiation of x square is 2x. So there is deficiency of 2. Divide and multiply by 2. It can be written as e raised x square times 2x dx. Now look at this. It's our function, it's our derivative. Where function is placed, it's power of e. That's the situation we have. E f of x, f dash of x. Its integration is only e raised f of x plus c. We have same situation, f of x, x square, f dash x, 2x. Differentiation of x square is 2x. This is e raised f of x, f dash x. E raised f of x, f dash x. F of x, f dash x. 1 over 2. It's our e raised f of x. It's f dash x dx. Its integration is simple. E raised f of x, 1 over 2 same. E raised f of x plus c. F of x is our x square. F of x is our x square. So we have 1 over 2 e raised x square plus c. E raised x square plus c. E raised x square plus c. Or one can write directly from here. 1 over 2 e raised x square plus c is our integration in that case. E raised function times derivative. E raised function times its derivative. E raised function times function derivative. Its integration is e power f of x by virtue of definition of the differentiation. How to handle base constant power variable, I have told you 3 times in that frame. Okay, cool. Moving towards next question. That's mine. 14 number. E raised tan inverse z. This one can be written as 1 times 1 plus z square dz. Now look at this. This is our function and this is our differentiation. Differentiation of tan inverse x is 1 over 1 plus x square. We are familiar. Differentiation of tan inverse or arc tan is 1 over 1 plus x square. 1 plus x square. So there is tan inverse z. It's our function. It's our derivative. Suppose our function is f of z is tan inverse of z. Its differentiation is f dash z is 1 over 1 plus z square. 1 plus z square. Put values here. It will become something like this. E raised f of z times f dash of z dz. Its integration is only e raised function, that's f of z plus c. Report the value of the function, f of z is tan inverse z. So we have e raised tan inverse z plus c is our answer in that case. Is our answer in that case. Okay. Cool. Next, nothing remains. Question number, I think 13 is good one. It takes time, otherwise everything work wonder. Let me solve 12, 11, 10, and there is 10 for you. Then I am about to embark upon this one, a good question to me, a good strategy. Here, let me solve 12 for you. Mine 12 is x cube plus 1 over 2x minus 1 over x cube dx. It's a simple integration. Look at, there is only x cube. Add 1 into the power, divide with the x raised 4 divided by 4. Having over only power 1, let me write ONE for you in order to emphasis on this, to give this one more clarity. X raised 1, x raised 1, it is case of ln, it is case of ln. If such type of question is present, having not power 1, shift into the numerator and add 1 into the power. Let's see how. X cube dx plus 1 over 2, 1 over x dx minus 1 over x cube dx. Simple integration. Add 1 into the power, divide with the same, plus 1 over 2, 1 over x, 1 over x. It is differentiation of ln x. Its integration is ln x. Minus, power is not 1. Simply, we are in a position to shift into numerator and add 1 into it. It can be written as 1 over 4 times x4 plus 1 over 2 ln x. Add 1 into the power, it will become minus 2, dividing with minus 2 plus c. Minus minus plus, leave here, convert this one into positive 1 over x square. Make this coefficient power of x, we can, by virtue of log property, we can 1 over 4 raised x4 plus ln x raised 1 over 2 means under root minus plus 1 over 2, shift x square in numerator plus c. That's our answer. Leave here, minus minus plus, write this one in denominator, write ln root x or 1 over 2 ln x, 1 over 2 ln x. It's up to you, it's up to you. You can solve 11 and 12 for you. Then I go to last question. Look at this here, only 5 raised x, 5 raised x dx. Base constant, power variable. Mark my word, 3 type of data are present. That is the second case. Normally, student is most familiar with that base variable power constant, and he is doing every differentiation question, every integration question with the same technique. Classify the situation. Look, there is x raised 5, there is 5 raised x. Big difference, big difference. How to differentiate this one? Let's see again. That's our base constant, power variable, right? Same. Differentiation of power, that's one, right? Base with ln 5. In case of integration, we have to divide with these two quantities. That is the case here. So integration of 5 raised x is same. Differentiation of power is 1 times base with ln 5. So we have 5 raised x, 5 raised x divided by ln 5, ln 5, ln 5, ln 5. That is the case. That is the case. I used to call it base constant power variable, base constant power variable, base constant power variable, and it will facilitate your work if you are familiar with this guy. Familiar with this guy. You must have friendship with that data, that type of data. Base constant power variable, base constant power variable, and there is base constant power variable, base constant power variable, base constant power variable, base constant power variable. You must have familiarity with data. Okay, then 7 raised 7 power 1, second last, 7 raised 7y dy. Look at this, base constant, power variable, same strategy, write it same, dividing with the derivative of the power 7 times y1, introduce base with ln 7. So I have 7 raised 7y divided by 7 ln 7 plus c. That's our answer in that case. That's our answer in that case. There is no need to enhance 1 in that. In case of differentiation, we cannot make the power coefficient and subtract 1. That is entirely different case. Base constant power variable. Base constant, power variable. How to differentiate this? Let's see. One time more. 7 raised 7. Right, same. Right, same. Differentiation of power. 7y means 7 times 1. Base with ln. ln 7. ln 7. So its differentiation is 7 raised 7y times 7 ln 7. 7 ln 7. In case of differentiation, we have to divide with these two guys. Differentiation of power and base with ln. We have to divide in case of integration. In case of differentiation, we have to multiply. Let's move to question number 13. Now we are in a position to take on this question. That is 2x plus 1 divided by x square plus 3 dx. Look, it is not a simple case. If you apply substitution, if differentiation of x square is 2x, differentiation of 3 is 0, not 1. Is 0, not 1. So we can split this up. 2x divided by x square plus 3 dx plus 1 over x square plus 3 dx. Differentiation of x square is 2x. Differentiation of 3 is 0, not 1. So 1 is something additional. We have split this as divide x square plus 3 with 2x as well as with 1. Here function derivative technique works. Differentiation of x square is 2x. Differentiation of x square is 2x. Here how to handle this? Wait, first let me handle this for you. It's our function, it's our derivative. Suppose in that case y is equal x square plus 3 for that part only. Even in that we can utilize, but it can be handled with some different strategy. Y is equal to x square, differentiate dy over dx is equal to 2x. Shift differential dx here. So differential of y is equal to 2 times x dx. We have value of this one, that is dy, and this is equal to y. Dy over, look at this, 1 over y, it is differentiation of ln y. 1 over y, it's differentiation of ln y. So its integration is ln y. We put the value of y, ln y is our x square plus 3, x square plus 3, x square plus 3. What about that part? Let's see and find out. X square, differentiation of x square is 2x. Suppose x square plus 3, differentiate dy is equal to 2x dx. So 2x dx, I have written dy over y. 1 over y is the case of ln y. Its integration is ln y. We put value of y, that is ln x square plus 3. We have done with this. What about this? How to handle this? This is the case I can write as 1 times dx overall x square. I can write 3 square. It is differentiation of tan inverse x over a. So one can write this one as 1 over, this is our a. Let me write formula for you. Tan inverse of x over a plus c. This is our x, this is our a. This is our x, this is our a. Replace values here. 1 over root 3 times tan inverse of x over root 3 plus c. So we have lump sum difference integration ln x square plus 3 plus 1 over root 3 tan inverse of x under root 3 plus c. If you are wondering from where comes or occur this one, let me give you the idea of magic substitution as well, how to handle this portion. Let's see. I have x square plus 3 dx. The general form for this magic substitution is dx over x square plus a square. In that case, we suppose x is equal to a tan theta. That's the substitution for this. Writing this data in that form, I can write dx over x square. Instead of 3, I can write root 3 square. Take the supposition, magic supposition that's mentioned. x is equal to a tan theta. X is equal to tan theta. Assume x is equal to a tan theta. We have value of a in our case is root 3. X is equal to root 3 tan theta. Differentiate dx over d theta. I have root 3. Differentiation of tan is sec square shuffle d theta over there. Differential. So differential dx is root 3 times sec square theta d theta. That's second value. That's our first value. Put here. So our question takes the shape like this. Dx means root 3 sec square theta d theta overall. X means root 3 square tan square because x is square plus root 3 square. Taking root 3 square common from the denominator, we have root 3 sec square theta d theta overall. Root 3 square we have tan square theta plus 1. From trigonometry, 1 plus tan square plus 1 is equal to sec square. Is equal to sec square in my case. Let me erase the data from here to manage the space. So it is root 3 times sec square theta d theta overall. Tan square plus 1 is root 3 square is there. Tan square plus 1 is equal to sec square. Cancelled out. Here remains only 1 over root theta outside. Nothing remains 1 d theta. Ask yourself, 1 is differentiation of what with respect to theta? It is differentiation of theta. So integration of 1 is theta. Integration of 1 is theta. 1 over root 3 times theta plus c. Find the value of theta from here that we have supposed. We have assumed that x is equal to root 3 tan theta. Shift 3 here. X over root 3 is equal to tan theta. In order to get rid of this tan, introduce tan inverse both sides. Tan inverse x root is equal to tan inverse tan theta. Tan no more. So theta is equal to tan inverse of x over 3. So we have 1 over root 3 tan inverse, or one can write or tan x over root 3 plus c is our answer. For this magic substitution, we have 2 to 3 supposition. In positive, we have to suppose tan. In case of negative here, sec. If a square first, x square then sine or cos, and partial fraction as well. These cases will be handled later and effectively. It's my tiny effort for you guys to share some knowledge about integration with you. Function derivative works wonderful for you. You should have clarity and familiarity with what is our base variable power constant, what is base constant power variable, what is both variable. If you have classified of these 3 data, if you can classify these 3 data, then your differentiation and integration concepts are have good foundation and they works wonder for you. Otherwise your building is going to collapse and might be there is some harm for you. It's all by itself. Next.